Okay. So today's agenda for the talk. First, we're going to start with the job board. Then we have this brand new segment called Industry Updates. It's a 10-minute segment, 10 updates, a minute apiece, super fast. So get ready for that. Then we have our first talk by Mr. Osterman. He'll be going over how to automate everything. Say hi. And next we have Flo, one of our own engineers. He'll be talking about Prometheus and basically how we replaced our legacy monitoring system. First, a little bit about GumGum. So we're a computer vision company headquartered right here in Santa Monica. So we have our main business is advertising. We do a lot of context-aware ads, and we have some brand technology. We also have a sports division, which I'll be showing off in a sec. And this is some of the technology we're with. So in terms of languages, we use lots of Java, Python, Node, TypeScript, using machine learning and computer vision software like these. Deployed with these DevOps technologies, there's a lot of them, all on AWS at crazy scale. Right now we're seeing larger than 20 million requests per minute with our ad server, which is ridiculous. And of course, we're huge fans of the CNCF. All right, so we'll talk a little bit more about our advertising business. So here's an example ad. So this is one of our image ads. So we're working with, I believe it was Revlon at this time. And they wanted to be able to understand the content of the pages they were advertising on, and specifically they wanted to only advertise where there's images of women. So this is an example of that. You can see how the in-image product is detecting that, and it's kind of displayed within the image itself. Here's another similar example where we worked with Acura. They wanted to target people that are also interested in BMWs, so we were able to detect that through NLP and CV. And did you know that we actually invented this? We have a patent on this. This is our in-image advertising, dates back all the way to 2008. Oh, and one more thing. So here's our sports products. So basically we work with every team in the NHL, NBA, I think MLB.
And the same kind of move, taking it to the baseline, stops to the Warriors.
The way the Timberwolves offense is rolling, they've got a chance to threaten that here tonight.
Cleared it ahead from good reception. Shot. He fights for a jack to Kane right to the goal. He scores! Hawks win!
Back off. In the end, Hammer couldn't get it back out wide. Prevail will not get a second chance at it. Carlos Vela!
Wade against Iguodala. 5.
So the job board. So first of all, so here at GumGum, we're expanding the DevOps team very fast. So we're actually hiring 3 positions right now, a mix of mid-level and senior. We work with a lot of awesome technology that you saw on the previous slide. So if you're interested, please hit me up. If you know someone that's interested, same thing, let me know. We might be able to give you a nice fat referral bonus. We'll see. But yeah, definitely talk to me because we have some amazing positions. We're taking the team to a whole new direction. Yeah, I'd love you guys to be a part of that. Anyone else have any job openings at their company that they maybe want to talk about? No, we can pass them away. Free advertising? No? All right. So let's get started with our new segment, Industry Updates. So since the last time we met, which was only 2 months ago, there's been a lot that's happened in DevOps, so I'll get into that now. One of the big ones is Ubuntu 14.04, Ubuntu Trusty. No longer valid version of Ubuntu. It's hit end of life, and this means that Canonical is no longer publishing security updates. So it's basically no longer supported. You must migrate away from this because it's becoming insecure. If you are, however, a paying customer, you'll see that you do have some slightly extended windows here where you can continue to get security updates from their private app repository. But if you're not paying for Ubuntu, definitely upgrade now. It's not a simple upgrade. They do change the system initialization from init D to systemd, so there are some migrations of your system scripts, but yeah, that's the way it is. And just so you know, that was from 2014. And you probably, maybe you already knew this, but these version numbers right here are actually the year they were released and the month. So you can look at a version number and always know how old it is. Next up is Shopify. So Shopify posted a great blog post about their testing of Istio interaction. So they basically benchmarked Istio against Linkerd, and they found that they actually hit a wall with this experiment, and that was cost. So from the documentation of Istio, they quote it as this proxy consumes 0.6 vCPUs per 1,000 requests per second, which I guess that sounds cool, but what does it actually mean? If you multiply it out, if you look at Shopify's traffic per month, this would actually cost them in Google platform another $50,000 a month just for their service mesh proxy. So, it's way too much, way too expensive, and that is per million requests, so it's actually much higher than that. In their particular test, they saw that the control plane for Istio by itself consumed about 750 microcores. And then they did the same test with Linkerd and found that for the same functionality, they only consume 22 microcores. So I know we get a lot of interest in Istio. We actually have people apply for jobs and saying, we just want to work with Istio. Like that was one guy who's like, I just want to work with Istio. But in fact, running this at scale is very expensive. So be wary of that before you pitch that at work. Next, we had a Stack Overflow breach, which was pretty bad. So this happened on May 5th. And they basically detected that a development release that was live, exposed to the public, had some exploits. And the same day that it was released, it was exploited. They then spent 5 days, looking around the system, seeing what other exploits they could have access to. And 5 days later, they exploited access to production at full access. And an internal investigation revealed that they leaked names, emails, IP addresses of Stack Exchange users, which is pretty bad, obviously. And to help this, they've hired a third-party forensic company to help them take other precautionary measures, but that was pretty bad. Next up was zombie load. So you probably saw this picture in the news. This is a huge, huge exploit that has to do with speculative execution. Basically, your CPU trying to figure out what we're going to do next to optimize and preload things. So yeah, it's very similar to Meltdown and Scepter, and it's really bad. Basically, you can access buffers at all levels, including caches in the CPU. And another interesting part of this story was, so Intel, they have a bug bounty program, but they typically don't like giving out the $100,000 reward for a critical vulnerability because it's basically them admitting that there's a critical vulnerability. So in this case, security researchers, they reported it, and Intel responded by giving them an $80,000 and $40,000 bonus just to kind of fly under the radar a little bit. So that kind of shows you that Intel, doesn't maybe have the best attitude about responsible disclosure. And in fact, Intel was telling a lot of researchers, don't disclose this for 6 months. So it's very dangerous, basically, for exposure methods. That's pretty interesting. And yeah, check out mdsattacks.com for the attack details. It's got some great visualizations of how exactly we should all be aware of. It's a bad one. And finally, for me at least, we had the Dockerhub breach. So you guys probably heard about this. So on April 25th, Dockerhub detected a brief period of unauthorized access to a production database. And after an investigation, they found that 190,000 accounts were exposed, which is about 5% of the total users. And this includes usernames, hash passwords, and Bitbucket access tokens, which is very, very bad. Or GitHub and Bitbucket access, sorry. So if you guys happen to use Dockerhub auto builds, please check that the integrated credentials, those tokens, haven't been compromised and they haven't been used. Maybe you can check for unexpected builds or pushes, that type of activity, and it's a good idea just in general to rotate your credentials. And some people might say, we don't deploy to Dockerhub, it's not a big deal. Well, in fact, Ken White on Twitter put it really well. Even if your company doesn't rely Dockerhub for production, any developer in your org has enabled auto builds via GitHub. Well, that OS could be compromised, which means every repository that developer had access to could be leaked. So yeah, even if you don't push Dockerhub, all it takes is one, and that's the way in. So yeah, be very careful. Check your webhooks, rotate your credentials. Yeah. Next up, we got Brian.
I will be giving the next 5 update. There's an Azure outage about 2 months ago. It was a DNS outage caused about 2 hours of downtime in Azure for anything related to their internal DNS. It was actually caused by migration from their legacy system to Azure DNS. And then, so it affected many Microsoft services, SQL Server. We were affected by Postgres, Azure Postgres, and then storage as well. Anything that uses their own DNS was affected. And then, so because of that, it affected all regions and all availability zones. And so even being region redundant, you wouldn't be able to get your services back up unless you jump out. And so this is actually a picture of every single region. I took these screenshots the day it happened because this affected us. And we're primarily an AWS shop, but we have customers that want to be on Azure because they see Amazon as a competitor, and so they strictly in the contract says we need to be on Azure. And so for us, we couldn't move them over to AWS during this outage. So we actually sat there and let them, take this outage for a good 2 hours. And so if you click on every single one of those tabs during this outage, all of them were red. Every single region, every single contract. It was pretty bad. Big thing for a lot of DevOps engineers, Terraform 0.12 was released. This has been a long time coming. They started mentioning it maybe like a year or maybe over a year ago. If you ever had any issues running, or if you ran into any issues on using Terraform, a lot of the times they would just respond with, hey, this is coming in 0.12. We're working on 0.12. It's a huge architectural shift for us. We'll get this out into 0.12. And so it actually got released. And some of the big wins was they've introduced a 4 operator. Anybody that used Terraform for a little bit, they know that initially when you start, you're like, how do I iterate and like create 10 instances or 10 EC2 instances? Have to use this construct called count, which was very different from what developers are used to. So now they've added that. Type system, they allow for complex types. Anybody that's used Terraform for a little bit knows that anytime they want to do anything more than a nested array, one nest deep, you can do that in Terraform, and so this actually allows you to do that now. So that's really cool. And then a lot of the objects are actually first-class expressions now, and so you don't have to do this string interpolation for everything. You can just do AWS VPC.dis.id. You don't have to do everything as a string anymore. And then what's awesome is they actually provided a migration script move from 0.11 to 0.12, and so you run that on your Terraform files, and they'll help you move over. Obviously, test after you do that, but it's really nice that they provide that. Not necessarily DevOps focused, but it is tech IPO season for some reason. Lots of companies in the tech industry are definitely IPOing right now. A lot of the more popular ones are like Lyft, Uber, PagerDuty, Zoom, both came out IPO pretty recently. Uncertainty in the market. Maybe some VCs want to hedge their bets now. They want to cash out, make some money. Don't really know. And then big names as well. I think CrowdStrike actually just IPO'd yesterday, I think, or today. Slack and Airbnb as well. And so ride sharing and consumer apps haven't really fared well in the market. But what I've noticed is a lot of B2B enterprise SaaS companies have done really well. So PagerDuty has been doing well, Zoom has been doing well, and I imagine Slack would also. But yeah. And then I think 2 weekends ago, a Google outage. This one lasted for twice as long as the Azure outage. From the RCA, it was 2 misconfigurations plus a specific bug combined all together became this very rare outage, or causes very rare chance of an outage. But lasted for 4 hours. A lot of Google services were affected. Gmail, YouTube, they saw drops in traffic pretty high drops, like 10 to 30%, I think, to these services. Many users of GCP were affected. Snaps, Shopify. I think it was like half the region, so not every single region was affected, but definitely a lot of the North American regions were. And then they said their cluster management software were accidentally included in the maintenance event that caused them to be shut down and basically causing a lot of services to go down as well. And then this was a little blurb about a guy who has a startup, and he wrote basically this Twitter thread about how DigitalOcean killed their company. Basically what happened was he runs a startup. He hosts his services on DigitalOcean. His company periodically needs to run this script that requires them to scale up their droplets. So basically scale up to run the script in parallel so they can finish the script in time. DigitalOcean's very naive, it seems, automation flagged it as crypto mining. And so they actually got their account locked, and then he emailed them to get it back up. The first abuse agent brought it back up, but forgot to flag the account as approved. And so with everything automation, it's just going to get taken back down again. And then so a second abuse operator basically denied his company access. He posted on Twitter. It actually got a lot of retweets. A lot of people were very upset with DigitalOcean that like this type of stuff should not happen when you're running a company, and kind of sucks for. And you have to think about this, that these cloud providers are definitely able to do something like this. DigitalOcean obviously reached out, got him back up, and offered more credits. But yeah, definitely something to be wary of with cloud providers being the ones that are hosting your service. So that's our 10, and now we have Eric doing his talk on Geodesic.
Give me a second here, get reset up. All right, let me get my slides so make sure they're queued up. All right, see that? Cool. All right, everyone, thanks for braving the traffic to West LA, coming out to another DevOps meetup. My name is Eric Osterman. I'm going to be sharing about a project that's near and dear to my heart. I've been working on this for the past few years. It's all open source, available on our GitHub. We'll share links at the end. So, Geodesic. So Geodesic is a cloud automation shell, and that might not mean anything to you right now. But don't worry, I'm going to clear that whole thing up. I'm sure many of you already practice something similar to what we do with a cloud automation shell. I'm going to convince you why this is totally awesome, and my goal is to try and convince you then to go back to your desk tomorrow and try some of these tools inside of Geodesic. Gum slide there with all those tools and technologies that they use, that was a perfect example of why a tool like Geodesic exists. I'm going to back that up with a live demo and a Q&A. Now, if things don't make sense or I'm talking too fast, feel free to speak up and say so. Otherwise, let's hold Q&A to the very end. So as I said, my name is Eric Osterman, and I'm the founder of Cloud Posse. We're a DevOps professional services company based here in Los Angeles, California. But we don't do just any kind of DevOps. We specialize in exactly one thing, and that's rapid cloud migration. But in order to be able to be fast at anything, you have to operate on a stable foundation, and that's what led us down the path of coming up with this Geodesic tool, which was born out of all of our customer migrations. So this package, or this tool, in addition to about 300 other projects that we maintain, standard boilerplate of infrastructure and configurations, are all on our GitHub. So I encourage you to check those out later. This is part of something that we call SuiteOps, and it's a collaborative approach towards DevOps. What happens so often is individual engineers work in isolation in different companies and end up reinventing the wheel 100 times over, 100 times a year. We get so much technical debt as a result of that. We're trying to solve that by collaborating on a similar platform that works for a lot of different people. We live in a pretty awesome time to be doing what we do right now. I started working with AWS back in 2006. It was a private invite-only beta Our startup was small, we were accepted, and we built everything to run in there. The only difference was nothing on this slide pretty much existed back then. Everything is new, and we had to go it alone. I liken this to being in kind of like a Renaissance period, where there's so much creativity and brilliance coming out from so many different types of companies. And part of that is because the know-how of how to do it has gotten better. Like, how do you open source stuff? How do you collaborate on projects? You know, how do you open pull requests? How do you do all this stuff? And it's become much easier to do. But we still do a lot of bad things as developers working on DevOps. And some of these things we don't do anymore as traditional developers working on web apps and things like that. But in DevOps, you know, we still run lots of tools locally. We build these really complex Rube Goldberg apparatuses that integrate with SQS queues and kick off this thing and run over here, and nobody really understands how it all comes together. You go to hire a new developer and you spend a week or two just getting their local development environment set up. And if your environment involves a lot of different operating systems or whatnot, it just gets more complicated. So when I open up a pull request, I'm doing development. I've obviously tested that, and it worked perfectly fine in my environment when I worked on it. It's my reputation at stake. I want it to work. I swear it worked. But then, you know, it goes to production or somebody else tries it out and it doesn't work. So this is what I'm calling the final frontier that we want to address, is how do we work in DevOps locally in a way that's repeatable for how we do things in production and staging and CI/CD context and all these other situations. Now, the reason why all of this becomes a problem is that our industry is overwhelmed with tools. Like we use Terraform, we use a tool called Kops for Kubernetes, Helm, Helmfile, Chamber, AWS Vault, and that's just to name a few. We have over 60 different packages that we manage as part of our tool chain. I'm sure you guys have some more. And then you combine that with the number of Amazon accounts you might work with or Google environments, and then the number of products in those environments, and all these things add up to an impossible combination of variables to account for on a single workstation. So that's what we want to get rid of. We want to easily automate these tool chains. How to use Terraform together with Terragram, together with Terraform 0.11 and Terraform 0.12, for example. And I'm going to show you how to fix this. But in order to do that, we want to think back towards a wise man who once said, the whole is greater than the sum of its parts. And who knew that Aristotle all along was talking about this? Geodesic. So Geodesic is really just a Docker image, and it has all the essential tools of our trade that we use to get our job done. And at the heart of it, it's just an Alpine base image that we run locally, like in our shell. But because it's a Docker image, we can run it anywhere Docker is supported. I'm going to make this a whole lot less opaque in a second with some screenshots and videos so it's more clear. So what have we done to accomplish this is an Docker image based on Alpine. We created our own Alpine distribution because the way most Docker images we see are installing custom software is that they're curling this package and chmodding it, and then curling this other package and chmodding it, and popping in these configurations. And that works really well if you're just trying to solve the problem for one environment and one person or one company. But when you're trying to solve that across lots of different AWS accounts, across lots of AWS customers, across all these things, we needed to just embrace the proven methodology of using package distributions. A couple other things we do, we use environment variables as much as we can because that's the lowest common denominator between all the tools that we use. We don't have the privilege of just using Terraform for settings because then we can't use those settings in Kops, for example. Dir-env, Gauntlet, variant. Going into the weeds here, I don't need to go into those things, but hit me up if any of those things sound interesting later on, especially variant. All right, so this is what it is in a nutshell. Now, this video has been playing here a little bit already, so I'm going to wait for it to loop around and reset. All right, here we go. So I'm running a command on the command line, testing.cloudposse.co. That launched a Docker container. I'm inside that Docker container. I assumed a role. I get the fancy little selector. I can select the role I want to assume. I'm typing in my MFA code, because we all do MFA, right? And then just showing you, look, it works. I can run the AWS S3 cloud. Now, this is a fleetingly simple example, because what's not represented here is that a developer who joins your team 2 hours ago is up and running within 5 minutes with your entire tool chain. He doesn't have to brew install this, brew install that, look at this README, figure out that it's totally out of date and doesn't work, and ask the guy next to him. And I guess that is a learning process in and of itself. But at least with this, you eliminate a lot of that process. What I described here sounds really easy. It's brain dead stupid simple, right? I created a Docker container, I put my stuff in it. If you guys are at a Kubernetes meetup, so you guys, I don't have to convince you why Docker is pretty awesome. And now we're just saying, let's run this locally as a shell as well. However, this has taken us, I think we're probably up to 330 or 350 pull requests at this point to get it right, just for a measly 3,000 lines of code. So a lot of thought has gone into it. So the gist to get started is easy. It's standard workflow. When you work with Docker, you have a Dockerfile somewhere. You're going to build that image, and we're going to run that, show you what that looks like. If you're not familiar with Multistage Docker, it's pretty cool. Depending on when you jumped on board with Docker, this didn't exist, so you might not have noticed it. But what's cool about Multistage Docker, I like to think of it in terms of programming like multiple inheritance. So you can have this Docker image, you can have this Docker image, and then you can pull those Docker images together with copy from somewhere, and you do it. So here in this example, I have first, the first line would maybe be your internal library compiled into a Docker image as an artifact. Then below there, we have Cloud Posse Geodesic. That's the image that we provide. You don't have to use ours. You can fork our public repo, build your own image. And then you can copy over your secret sauce into that image. We never see it. We build it, we run that. Now, this is kind of interesting. I'm not sure if you've seen this. Many of you have probably seen and used the Taboo, the curl bash pattern to install tools. A lot of like AWS tools come that way, or Google Cloud. We've kind of coined this the Docker bash pattern. And what we do is we ship a shim or like a wrapper script inside of our image that when we pipe it into bash, it just sets up our environment so we can easily run that container. Because running Docker containers by hand gets boring really fast. Like typing out the arguments to a long Java command or something. So when we do that, then we can run this command, user local bin my image. My image is a placeholder for what your image was. And here's what that looks like. Again, the video's been already playing, so it's not starting from the beginning, and it's resetting here in a second. And there okay. So here you see what a directory looks like. There's a Docker file. I run a make target called make build. It builds that Docker image. I run make install. This is running that curl bash pattern to install, or the Docker bash pattern to install the script. And now I can run that script, testing.cloudposse.co. Now, one thing we do that's kind of controversial, and I'll bring it up again later, is you notice what my script was called was testing.cloudposse.co. And that's because the way we organize our infrastructure is interesting. We treat an Amazon account like an application. So that application gets a dedicated GitHub repo. So if you have multiple teams, multiple accounts, they each have their repo and they're not stepping on each other, and they have full control over the permissions and all that other stuff. So in this case, the Docker image is just called what we call that account. Well, at least this much seemed pretty simple. The devil's in the details, and I'll maybe point some of that out. But what we've achieved by doing it this way is we have a super portable workflow. So it's a Docker container. We can run that wherever Docker runs. We can put all of our commands in there. So if we're running Terraform with Make, with TerraGrunt, with Chamber, with AWS Vault, it's all in there, all automated. It's stable. So we can be using newer versions of packages in the dev account, and staging account, but production uses a stable version. And when we want to promote the version of all the tools that we use, we just bump that image that we were referencing. So from Geodesic and the Docker image that we were pointing to. So it's very easy to roll forward and super easy to roll back. And you don't have to worry about compatibility. So what I described is what makes it stable. It's auditable since all these configurations and changes are stored in GitHub versus the local developer typing brew commands to install packages is not. Now, the elegant thing I've seen some companies do is they run Ansible to configure like their local dev environments. I guess that's a nice workaround. What I like about this is you automatically know what interface or release somebody's on just by the version of Geodesic they run. And it's usable. So like anyone who can run a Docker container can now use your DevOps toolchain. So we use this for Terraform, Kubernetes, Helm file. I'll show you that. We also use it for something called Teleport, which is like an enterprise-grade SSH system. I can briefly show what that looks like. Our community is using it with all these tools like TerraGrunt, Jenkins, Ansible, AWS, GCE, GKE. It really doesn't matter. And it runs on OS X, Windows subsystem for Linux, and obviously Linux itself. So the summary here is basically, if you can run it on the command line, you can run it in Geodesic, so give it a shot. Our best practices for using Geodesic is this, where we have one container per AWS account. That's worked out well for us and how we organize things. Your environment might be different. Maybe you have one container per cluster, or maybe you only have one container. Maybe it's overkill to have 7 different containers for each different account. It works different ways. Using code owners, so now we have this container, we can enforce that certain people with subject matter expertise are involved in any changes. So like if changes to the version of packages are made, well, your package maintainer in your organization will let you know if there are any caveats with that. Since it's a container, we can run it with CodeFresh. CodeFresh is a CI/CD service that we really enjoy. Even Circle CI these days lets you run container steps very easily. Atlantis, anybody using Atlantis for Terraform? This works really well with Atlantis. And that's that. All right, so we're at a point where I can do a demo here. Let's see how it's going. Let me check my battery first. Oops, I've been disconnected. Let me reconnect here. Any of you guys use AWS workspaces? These are pretty cool. They're like VMs run by Amazon that you can RDP into. I use it so that all my work is always in the cloud. It never leaves. Doesn't matter where my laptop is. My work is always in one place. There's a great advertisement. There we go. Let's give this another shot. All right, one second. Just gonna make sure not to make any faux pas here. All right, so that's starting up. Share my screen again. We'll get back to that later. All right, so I'm inside of a project folder here. It's called testing.cloudposse.co. If you go to github.com/cloudposse and then just testing.cloudposse.co, all this code is there. Inside of here, I have the Dockerfile. It's a little bit more advanced than the one you saw in the examples. This actually shows you what it looks like in practice. We have a lot of environment variables set in the Dockerfile as constants that relate to this environment. And then when I want to go ahead and build it, I'm just going to run that command. So make Docker build. Oops. I'm going to install the wrapper script. I only need to do that one time. And now that I have that, you see it installed a little script in user local bin. Nothing fancy, not going to go over it line by line. All it does is in the end, call Docker to run it. And in user local bin, you see, I got a bunch of those things. I got things for li or rms.pub, even.io, prod.cloudposse.org, joni.net. All these are different customers. And that's what makes it so easy for us to jump into one customer environment, complete with all of its tool chain, without it ever affecting another customer and their tool chain. So it's a very stable way of operating. We had to work this way because it was the only way we could satisfy working with multiple customers concurrently with complex stacks and tool chains. All right, so gonna jump into that shell. And here we are. So now I'm just in a regular Linux shell. It happens to be inside of a Docker container. There's a few little things running inside of it. AWS Vault as a server, so it makes it easier to authenticate. Since this is a demo environment, I'm just going to type MFA here, which gives me my one-time password. Copy that and assume roll. Cool. So I'd actually authenticated earlier, so my session hadn't expired. That's why I didn't need to type my MFA code in there. But ordinarily I would if it would have been over an hour ago since I last did this. All right, so now, like in the video, AWS S3 LS just works. I can operate with Terraform if I wanted to. So I could go into like our ACM project folder here, and you saw a bunch of stuff show up here. What is all that stuff? Well, that's a dir-env. Dir-env is a way of managing your environment settings per project folder. And since we use environment variables for everything, that works really well. And I can run Terraform init, which initializes this project, connects the remote state, and it's been initialized. But the beauty with this is everything I've just done now locally, since it's in a Docker container, I could just as well have done in CI/CD, and it would have used the same exact version of the tools, the same exact configuration, everything would have been the same. So as a developer, I'm testing the same thing that I'm automating. And that's what I mean about making it easier to automate complex workflows. Cool thing I wanted to show you is teleport, just like as a cool tool that we ship with this. So if I type TSH login here, so let's see here. Guess there's something wrong with DNS. Do you guys not allow like general like Cloudflare DNS?
On the guest network. Yeah.
Okay. So never mind that demo. That'll be for another time. Would have been really cool. Let's see. All right. So demonstration that what we have here can now run very well anywhere else. So I'll show you two examples of that. One example would be CodeFresh. CodeFresh is just like Circle or Travis, only better, especially if you work with Kubernetes. We have a build here I ran earlier. All right, so we use a lot of Terraform. 140 Terraform modules are on our GitHub. A big initiative we have right now is adding automated testing to that. So if you've heard of TerraTest, adding TerraTest. Well, this is actually pretty easy for us since we already have this container that represents our testing account, testing.cloudposse.co. All I need to do is make sure I get that code in there for the module and run the examples for TerraTest. So if I look at this example here where I run the tests, let's see here. Here's where I run TerraTest. I'm going to look at the YAML step. Here I'm saying, take this image, test image. Test image is just a variable that actually says cloudposse/test.cloudposse.co. And then commands. This is the command to run. So we use make a lot. And this is just going to go into the test/source directory where the TerraTest stuff is and run that. And what does that look like? Well, that looks like what you would see if I had run that on the Linux console earlier. And you just see all the output stream here from when I ran that test. Now we do a bunch of other steps. We're running BATS, which is like the Bash automated testing framework. And we're testing like the module, we're testing the examples of the module and all of that stuff. Then Atlantis. Have you guys heard of Atlantis at all? So Atlantis is pretty sweet for Terraform GitOps, basically continuous delivery of Terraform code. Thing is, you need to run Atlantis somewhere. What most people do is they just use the official Atlantis image somewhere. And that's great if you only depend on Terraform. But maybe you want to use Atlantis to manage your COPS clusters, or maybe you want to deploy your Helm files, or maybe you want to run any other, like some raw AWS command to provision CloudFormation or something. Well, you can use Atlantis for all of that. And we have an example of that. So if I go here to a pull request that was opened up by one of our developers a little while ago, you can see the files that changed here. So he bumped a version of our Terraform modules. We do something called this Terraform init-from module, some remote source. If this doesn't make sense to you, I'm not going to go into it right now. But that's why you don't actually see any Terraform code here, because we're doing a reference to some remote code. But what that all means is that here we see the output of running a Terraform plan. And that Terraform plan ran inside of that Docker container that I just showed you. It's just that this Docker container is running in ECS and has an IAM role associated with it so that it can run these permissions. And here we see the output of that. So here's what's going to change. And the output of this is kind of pretty. We pipe it through a command called scenery. Again, if you were running just the official version of Atlantis, you couldn't pipe anything through scenery because it doesn't ship with scenery. So the whole idea is to pack all these useful tools inside of your container and make it easy. All right, so that's basically the demo that I had lined up here. I was really hoping to show you Teleport, pretty sweet. Basically, I could be in my shell over here typing commands to the server, and then somebody else can be auditing that in a web browser at the same time, and we could be pairing. And that's one of the things that's enabled by using Geodesic. Cool. Let's go back, see where I'm at. Slides. All right, so that went pretty well. Start this up. All right, so the links here for everything that I've shown today, if you go to Cloud Posse, is Geodesic. It's also one of our starred repositories. And then an example for how we use Geodesic in our testing environment, that's where you go to this testing.cloudposse.co. We have this Slack community. Couldn't avoid a shameless plug here. Definitely do check it out. If you are especially like an engineer working in a silo, you know, there's not many to bang ideas off of, or if you are just venturing into something new and you want a friendly place to ask questions. We're almost 1,000 strong, many based here in Los Angeles, many using the tools that I talked about today. And that's it. Thank you, guys. Any questions about Geodesic or anything else you saw?
How do you prevent people from, like, in a development environment, like Java is easy to more advanced, or like newer version of the, how does that secure environment allow?
Yeah, exactly. So we have a GitHub repo for our dev account, for like a sandbox. Then we have a GitHub repo for staging and prod and all that. And that's what's allowing us to version our tooling along the way. You could technically do this in a mono repo, and you just have a Dockerfile and different subfolders. We've just found that amazing things happen by embracing lots of repositories. All right, cool. All right, thank you, guys.
right, still with us? It's gonna be dense. I mean, one after another. Yeah, your share screen is better. Here we are. So welcome everybody. Thank you, Eric, for, where's Eric? He's a bit over there, too close. Thanks for the talk. That was really great. I think I'm gonna just make some connections with your talk in the future. So we're here to actually talk about how we ditch our our monitoring systems and went with a more modern monitoring tool at GumGum. And I'm just gonna walk you through all of this. My name is Pro Indemrin. I've been with GumGum for now 5.5 years. I kind of recognize some of you from past meetups. I've been really active in the Ansible meetup, but I'm super happy to be part of that DevOps West LA meetup group tonight, given that I'm in France on Saturday. So just for the note, I felt like that was completely legit to say that I was the one setting up the legacy monitoring, and I'm gonna be the one tonight trashing it, and I'm gonna be the one explaining you how we improve that. And I was mostly involved in that project, so I'm somehow catching up on my own mistakes. Well, per se, that wasn't a mistake, but let's just talk about the complexity of that modern world. As Eric mentioned, we keep using more and more tooling. We keep using more and more automation tooling and containers and Kubernetes, and all of this has an impact on the monitoring aspect of like, how do we monitor that ecosystem? So we're just gonna go over a couple of things around what is the monitoring we're looking like today, and be prepared to adapt yourself and adapt your monitoring system to newer technologies. We'll just go over our legacy monitoring system, and that would be pretty interesting to see how we actually patch that legacy monitoring with the new monitoring system that we adopted, which is obviously Prometheus. I would just cover, so don't expect a YouTube-like video, Prometheus demo. That's not what's gonna happen. I really want you to understand like how we embrace that problematic of like giving up on the monitoring solution, which is at the heart of your whole infrastructure, and how we actually tackle that pretty big project of like moving away from a monitoring solution to another, given that we run pretty much like 2,000, 3,000 hosts on AWS across multiple accounts. So we'll just show you like all the benefits and things that we've been thinking about to enhance that. All right, so let's go back in days where things were really trivial. You just had to monitor pretty much one single host or a couple of hosts, but those servers were acting like individually. You just add a bunch of hosts, so that one is Nginx, that one is a database. I know what kind of like checks to perform on each of them. So that's a really trivial monitoring situation. Now with cloud technologies, here comes auto-scaling groups. So auto-scaling workloads where you can end up with at a certain time, like a certain point in the day, you get like 3,000 hosts, and at night you get 20 of them. How do you make sure that your monitoring solution doesn't trigger false alerts when your hosts are going up and down, because it's just a normal behavior, right? So that's part of the things that we want to capture in our monitoring solution. Now, talking about containers, great. Now we know how to monitor a single host or a group of hosts, but now we have to deal with a bunch of containers running on the same host. So it's even more complicated to get there. And I'm not even talking about like external services where you may want your developers to have a point of, information coming from different cloud providers, coming from like, how many messages do I have in my SQS queue? Well, I don't know. I need to log into CloudWatch. And on the same time, I'm watching this other tab where I have the rest of the monitoring. So we really wanted to address like all those problematics and fix our monitoring system so that we can have one single tab or tool to look at those like metrics. Let's go through our wonderful monitoring system, the legacy. Part of the tool, I mean, when I say monitoring, like don't take it wrong. It's definitely, I mean, legacy means just like where you stand versus where the world stands. And we basically as an engineer take some actions or make some choices back in the days because they made sense. But with like today's technology, whatever choices you made might not be the correct ones for today's needs and services. So Icinga is per se not a bad tool. It runs pretty well. It used to monitor like 100 hosts with a single instance, so pretty good. It's actually Icinga 1 was a fork of the Nagios project, and Icinga 2 is actually a lot better. And we used that monitoring system for 5 years, and that was good. I mean, overall, pretty good experience. Offered an API to control like downtime or remove downtime on certain hosts. You can see that the web UI is not too bad. It's kind of like web 2.0. So not bad as a system per se. The only thing is you have different ways to configure Icinga, and you can configure it, like you can configure all the monitoring on the Icinga server itself in the configuration, and really easily apply a set of service to a bunch of hosts. So that's the way we did it. We used to reconfigure Icinga based on AWS tags and just say, hey, give me all the hosts that are running in that AWS account. And based on specific tags, we knew how that host should be monitored. It says, hey, I have a monitored services tag that is set to Nginx. So, oh, I'm a web server. So Icinga knew that it had to check certain ports and certain behaviors. That's a wonderful email from Icinga, which that you don't want to receive at 2 in the morning. The second wonderful tool that comes with Icinga in some ways is Nagios NRPE. I'm sure a lot of you are familiar with that tool. I'm just not gonna go through that. I just wanted to show how beautiful is that like configuration file. One thing that I want to mention on this slide is the problem with Nagios is that you install agents on a remote servers and you pretty much define how you want them to be monitored. And it's kind of stupid because if you think about like a cloud environment where a certain type of service can be installed on a T2 machine, but if you want to scale it up from stage to production or change the instance type, actually the specs of the monitoring are changing because you might be running on a bigger box or like more memory, more CPU. And that thing is kind of like really static. Like once you drop that file, it's like, it's done. You will be monitored that way. So it's just better to, I mean, I just feel like having those checks being performed on the machine, but then be reported to the monitoring and having the monitoring making decisions on how to actually alert is a lot better. But it is, that's what we had. And to finish with, I think one of the best one that has been there forever. We kind of like never got rid of it because it was addressing one single thing that others were not doing, just the fact that it offers a view at the cluster level. So you can actually say, oh, I consider that group of machine as a cluster, and you can see that beautiful heat map over there, or all those like flame graphs. So that just tells you how the cluster is behaving. So here you can see we have like 33 hosts. So you can see like the big picture at a higher level, or like a it offers you a grouping logic on top of your host. And that's what is quite interesting. Now let's just cover, that's basically the POC that I led when I start to get rid of the legacy monitoring. And I just came up with pros and cons for each of the systems that we had, and in order to understand which one we should get rid of. So you have always Icinga, Nagios, and Ganglia, and on the other side, different type of services that we've seen before, right? Static hosts, autoscape hosts, groups, containers, and what I mean by services is external services. Let's say you want to report CloudWatch metrics into your monitoring system, or you want to get information from a Kubernetes cluster that says, hey, how many pods I'm running there. So this kind of information. So that gives you an idea of like what's going on. As you can see, we have a lot of red crosses on the container area where we were definitely not ready to monitor on that field due to the tooling that we were using. No custom application metrics collection. The problem is when you have a monitoring system, you might want to actually start digging into your own metrics, like, oh, how many requests of that type I'm doing per second, per minute, or whatever. It's just giving your developers a lot more visibility on what's going on versus, oh, you're making X amount of 200 requests. Sure, it's perfect, but it's like, what type of request is it? Like, is that critical? You want to track a specific behavior, so you basically cannot with that type of system, at least with an easy path. The second point is about data collection, data aggregation. So what you want is collect metrics and then aggregate it in some ways that it makes sense to you. What if I want to see network traffic over availability zones so that I can detect if my AZs are balanced properly or not? What if you want to see whatever, like any kind of metrics that you want to group by clusters, by regions, by whatever you want. And here we're again limited. So you see like a black hole in the middle. I'm just gonna keep going there because you'll see at the end the recap matrix that gives you a good overview of like how all those things look like. Data visualization was also, I think, even a bigger problem in a way that we didn't have like great tools that gave us a good visualization of what was going on. I think that was great. It was green is up, red is down. Sure, okay, and what else? That's it. So not just reporting metrics and Ganglia, we saw kind of like a few things, but I'm sorry, Ganglia, but not a pleasure to play with. I mean, it's not like really friendly. It's not really new, and you really want something, you want like a good experience, especially if you offer that experience to your developers so that they can dig into problems or production issues. Other thing, I think it's definitely the most important point and the most, actually, the harder to fulfill. Other thing, you always, well, you have like different ways to alert based on symptoms or causes. It's like, if the disk is going high, you may send an alert. If the CPU is high, you may send an alert. But if the CPU is high, but the machine is still behaving properly, do you send an alert? It's like, is that worth it? So there are like really like different type of monitoring. As I mentioned, causes based and symptoms. So you see that there are like a lot of 500s or things like that. Then you might want to dig into, whoa, 500s are pretty bad for my system. I actually don't care if my CPU are overutilized and I don't face any issues. There is no problem per se. So what we really wanted with our new monitoring system is to eliminate any kind of alert fatigue. Like, how many of you got like, I don't know, 10 messages when you lose a host? It's like, oh, that host went down. Yeah, sure, I get 6 emails because I'm monitoring 6 different things. Like, why do you send me 6 emails? Because I know that host went down. So you really want to make sure you capture that. It happens to us like so many times that we get 60 emails when someone decommissioned a cluster and we haven't snoozed notification on the monitoring. So that's part of the things that, I mean, for a DevOps, it's like, haha, you forgot your maintenance. And for developers, like, what is going on? I'm getting 60 emails at once. It's like something is bad and something is happening. So just think about that and think about it and make sure that you can, I mean, give you the needs to just offer you a better monitoring solution, which is just even just better for you just in terms of emails volumes. As a recap, here is my heat map, which kind of like, where's my manager? It's not there. Well, my +2 and +3, so that's good. My +1 is here, it will bear with me. So yeah, that's kind of like looks crazy, but back in the days, that's what we had. If you think about the old school world, so well, actually how I computed that, we saw 4 different categories, and based on those 4 categories, based on the thumbs up or the red cross, I just computed an average. And this is like per system. So the big problem, and we can see, I mean, actually I learned a lot of things while doing this. You see the containers area, it's like the dead zone. We don't know anything about containers. And it's kind of scary where you started productionizing containers and people are pushing on, well, yeah, let's do more containers. Like, well, are you sure? We don't know what's going on. So it's really time to react and patch that system, like this area over there. So let's see how we fix that. And by like doing a POC and looking at what tools were out there, we just found like a great ecosystem that could potentially fix all our problems and turn that matrix back to green. Let's jump into it. So on the Prometheus side, Prometheus, for those of you who are not familiar with Prometheus, it's an open source project, CNCF graduated, which is kind of important. So for those of you who don't know CNCF, it's a cloud native foundation. And they basically sponsor like a lot of, or guide, it's like somehow the Apache Foundation, or like, it's like a way of thinking and a way of developing open source softwares to make them scalable. It's kind of really interesting. They have a big landscape. Kubernetes was one of the first one, actually the first one. And Prometheus is getting a lot of traction. So you know that if a project is CNCF graduated or whatever part of the CNCF, it will head towards wherever Kubernetes or scalable systems are going. So it's kind of like a nice bet in a way that you're investing in a project that will keep moving in the future. It's 7 years, was founded 7 years ago, at least the first commit. And I think the most surprising fact is that it's a pool model. So a single instance is actually pulling metrics from thousands of systems. And a lot of people might ask, well, but does that scale? Well, I just drop a link, like that pool model is a link to the Prometheus blog post about pool versus push model. And it's actually really interesting to read. So I really encourage you to click that link and go have a read. But it's not only, they thought about like systems that could potentially not offer that interface that exposes, at the end, it's just a simple API that offers a / metrics endpoint and that says, hey, here are the metrics that you can consume. Thank you. If you cannot afford having an HTTP endpoint, or you feel like it's an overkill because you run an asynchronous process that consumes from a queue and just do some processing, you can use also other tooling that I will talk about right after. What's amazing about Prometheus is that it's a single node server. So you run Prometheus, you don't have to set up a whole stack of systems or databases. It stores all the data locally. How do you get high availability with Prometheus? You run 2 Prometheus instances that do the same job. If you lose one, the other one still has data. Roughly the same. I agree with you, but at the end, it's metrics. So, it's just the way to see things, but that works pretty well. One of the big feature that we were looking for using Prometheus is the fact that we can discover systems on the fly, either with a static configuration or also plug into a service discovery system and get knowledge about what's going on. And finally, the PromQL is the language that you use to query metrics on Prometheus. This is the slide that I spend the most time on ever in my life. Here is our matrix. So remember, each column is a tooling that we're using today. Each row is basically static host, group of hosts, auto-scaling, containers, and something else. Here is how we design our system. We started everything back to the EC2 machine because we said, sure, EC2 was here back in the days, and we still need to take care of the legacy EC2, even though we are super hype and we run containers. So in order to do that, we said, well, one problem we had to solve in EC2 landscape was the fact that systems were auto-scale. So one host can come up and come down at any time. but maybe for a good reason. I mean, a host becoming unhealthy because it just received too many requests, you should fire another, but an host like scaling down and just normal behavior should just simply deregister from that system and say, hey, I'm not here anymore, don't take care of me. On the other side, a new landscape that we had to address, which is the container landscape. So you can see from our heat map over there that we patch a whole bunch of squares with orange just yet, because we're just at the discovery part of it. We're not monitoring anything. How do we do that? The monitoring, the registration part in the service discovery. Well, I'm just gonna keep moving there. So obviously we use console as a system discovery, service discovery system. The way we do it with containers is that we run an agent. So we run the console agent that is interacting with the console cluster. It's exactly the same way EC2 works. And we use that dotted logo, blue logo, which is a registrator from Glider Labs, which basically listens on the Docker socket and sees every new containers going up and down and taking actions with the service registration system console. So whenever a container is being shut down, it registers it from console. And whenever something is started, it registers it under a specific section. So that gives us now a way to control both containers and EC2 in somehow like a similar manner. We just register ourselves in a service discovery. Be ready, because it's a full flip to green. That's a lot at once, so I'm just gonna try to cover that one by one. Everything starts with the Prometheus ecosystem, so the first block. So that whole new block is actually running today on ECS. We decided to adopt, I would say, a flexible solution to deploy our containers over there. And you basically have two Prometheus instances for high availability that are actually doing the same job. So what those Prometheus servers are doing, they ask the service registration system to learn about hosts that should be monitored, and based on what information is in there, they will connect directly to the host or container to get information or metrics from them. On the right-hand side, you have the Grafana monitoring. So Grafana is simply the UI that allows you to visualize the metrics that Prometheus has gathered. We also run a pair of Grafana instances for high availability requirements. And then on the other side, we just underneath Grafana, we have external service exporters. Remember that external services monitoring is something that we want to achieve. So part of these are CloudWatch reporting, SQS monitoring, these type of things that you just simply get from AWS or get from Google Cloud or get from anywhere where you can get metrics and just insert that data in Prometheus. And on the left-hand side, you have Alert Manager monitoring domain. So this will be additional tooling to fulfill the monitoring ecosystem. So we have visualization, we have data collection, but we're missing alerting. So the alerting part is controlled by Alert Manager, which I will cover right after. And the push gateway, hopefully, is also over there. The push gateway is the one that receives metrics from services that don't expose such a metrics endpoint that Prometheus can collect. Now you get to the unicorn monitoring infrastructure because you just added a MySQL database to store all the Grafana data. You're adding a hot mechanism on top so that people can log in with your Gmail account. And you finally add the last layer, which is just the access to that whole thing. So we want it to be fancy and have TVs displaying Grafana metrics, but for that we have to open our monitoring to the outside. We scoped it to the office so that we are like all control. So you can go pretty fancy, but at the end, I think that's an ecosystem that works pretty well. We've been running that stack for about a year now, maybe less than a year, but it's working pretty well. We are making changes to it and it's pretty smooth. And we keep adding new monitoring. It's so easy and so pleasant to just work with that type of monitoring. So that's pretty much how we set up Prometheus at Gumgum. Now let's get a bit deeper. I'm just gonna cover some basics. I just don't want to be too long on that. Just global configurations is how often do you get to your metrics and how often do you collect those metrics. Remember, it's Prometheus acting on all the servers that are under monitoring. We have then the alerting part. So that's where I want to actually stop talking about the service discovery system where we actually use it over there. We just define a console config where we have a local interface that forwards everything to console. And what we tell here is that we are only interested by the alert manager service, which is on the screenshot over there. And what it will tell console is that whatever information is here with IPs and ports, Prometheus will be able to forward all the alerts to that system over there. And finally, you have like a rules file that stands on the Prometheus side. That's the way you want to create your alerts and the way you want to forward, like whatever, like detect whatever problems you have in production. On the other side, when you actually register, when you actually have Prometheus scrapping data from console, you end up with the left column over there that gives you a bunch of metadata. So those metadata are based on system discovery systems, or if you're using console, you will pretty much land with those metrics. If you're using something else, you will get something different. But at the end, what I want to focus on really quickly is the fact that you can leverage the the fourth one from the bottom, which is console, meta console tags, which is a list of key values separated by commas. It's like a CSV of key values. And what we tell here at the bottom, the scrape config says, whatever is named, I'm gonna name a job named Prometheus. It's gonna be based on whatever is in console. I want to focus on the service equal Prometheus. So remember on the left, right-hand side, that was Alert Manager before. Let's say we have one for Prometheus. You can have one for your Nginx applications or whatever XYZ application. And what we do relabeling configs. And what I learned while doing that POC is that relabeling is the key. By using relabeling, you basically enable you to create filters that you're gonna be able to use with your Grafana system afterwards. So what's happening here, there is a dirty regex over there that says whatever is basically between a comma and an equal, we just extract the key and the value. And what we achieve doing that is that we just accept random key values into your monitoring system. So whatever we drop in, whatever we drop in that list, so here you see we have cluster equal blah, ID equals something else, and AZ equal US East 1E. What you end up, so that's how Prometheus discovers your system, and that's how Prometheus interprets this row over here and stores that data at the end in its system. So you know that at the end you will have AZ as a filter for your data or time service. Or ID or cluster. Cluster is actually a bit better. Let me jump into Alert Manager really quickly. So in Alert Manager, you basically define all the rules on the Prometheus side. Alert Manager will be the component that is sending you alerts based on whatever Prometheus is sending to Alert Manager. Really quickly, you define different rules. Here you can see we have a rule named Verity, which is one of our products. And we try to monitor the number of 5XX that have happened. So here you see a beautiful expression of a PromQL language that definitely takes a bit of time to understand and play with. But at the end, you have like different time series and you have a way to filter based on some labels that you draw. That one should be well known now, like the cluster one. We have that ability to filter by cluster because we drop the proper relabeling rules that extract that value and allows us to use it here. So labels and relabeling is really, really important. You'll notice the whatever, like some different syntax to catch regular expression or like exact match. So what we're trying to do here is that for the past. So for 1 minute, we're gonna wait and inspect for the last minute what happened over like whatever requests were a 5xx, and we're gonna alert when this increase is greater than 20 over there, and we wait for at least 1 minute. So we need to observe that phenomenon, that thing for at least 1 minute. And whenever this happens, we emit an alert that will go to Alert Manager. Remember that green file here, which is captured in Prometheus. So we jump to Alert Manager now. What's happening is in Alert Manager, you will be catching whatever behavior is being sent from Prometheus. So you have a way to group alerts based on alert name, service, or backend. You can also wait, like when you get the first alert, you can say, all right, I'm gonna wait for a certain time in case there are like more coming in. And here you can define routes that says, oh, if the service that emitted this is tag name ABC, then you send it to a receiver ABC, which we're gonna go right now. We're gonna see it. Alert Manager has a great feature, which is the rules like the inhibition, which allows you to basically stop sending emails if, let's say, you've received a critical email first, and then you can say, well, those ones are warnings. So I was talking about getting 10 emails at once when you have a host going down. Well, here you can say that type of feature will prevent you from receiving more emails, because we know obviously that you're most likely gonna get warnings emails when you get a critical. And you can do fancy regex matching, filtering, etc., etc. On the receiver side, you have a lot of integrations, which is definitely really, really good. Our plan at GumGum is to, well, right now we're still leveraging emails. That's the easy, straightforward way to do it. We also want to leverage the Slack one and to actually mature and learn from our alerts. And whenever the Slack notification are really accurate with real production issues, we want to send it to PagerDuty and fire some code, some pager. And you have on the right-hand side an example of an email that is being sent. A lot better than Icinger. You can actually templatize that. And finally, we have the Grafana layer, which is the UI that allows you to see what's going on and interpret your metrics. In Grafana, you have the concept of data sources, which are not unique. If you're using Prometheus, great. If you're using InfluxDB, great. You can mix all of this within the same type of dashboard. So that's really, really interesting. So here we define a simple Prometheus data source that we're gonna leverage to display or to do like our graphing interface. So you can see it's based on like multiple panels, where each panel is actually defining a Prometheus query that you can see here at the bottom. So I'm not gonna go through the details of that. It takes some time to learn and understand a bit like what are like the different functions. So definitely go check it out on the Prometheus documentation, but it's a really, really powerful tool that allows you to do sum average. You can calculate an increase based on a linear like time series and things like that. So really, really powerful visualization tool. I think part of the game was to give you tips. So here it is. Take a pic, do whatever. I mean, the slides are available at the end. Just a hint, I'm giving you basically one of the slides that I've really enjoyed at KubeCon in Barcelona. And it's talking about how to use like the use and read method for Grafana and dashboard like designing. This is really, really interesting, and it's definitely worth the read. We really want to get to that. It's a clean way to actually design dashboards. I couldn't just like pass through, and I wanted to have like a view of it. So this is like the red method, like explained. So you have basically one row per type of system, and you divide it by 2 columns. On the left-hand side, you have like query per second. So you have the rate. And the rate and errors, actually, you have the 2xx and 5xx. It's a bad example because they don't have any 5xx. And then on the other side, you have duration, so latency. It's actually a really good methodology to dig into production issues. Even with Kubernetes, you can think about it at the node level, the namespace level, the pod level, and so on and so forth, and dig into your systems. Really encourage you to check that out. And there's a link over there as well with Weaveworks. They do really, really great blog posts, so check it out. And to wrap it up, as Corey mentioned, we're hiring. If you're really excited to work on this type of technologies and this type of infrastructure, reach out to us. And if you have any questions, I'm here to answer. Thank you. Yeah.
Did you implement by yourself, or did you lean on any? Sorry? It's a mic. It's a mic? Yeah, yeah. Really? Did you implement this by yourself, or did you lean on any integration company or support company? Or is it just all open source Wild West for you?
Yeah. So I would say that I basically built based on what we learned. So let me just recap over there. I'm just trying to rely on either technologies that we are pretty well mastering or that we know pretty well, such as the ECS stack and all those things, like those patterns with, you can see traffic here. You might not be familiar with all those technologies. Traffic is a microservice router. It's like HA proxy, but really dynamic for containers. To be honest, Consul, we've been talking about Consul for years and years, and at some point we say, well, let's do it. It's like we need it, and I mean, we're not experts in Consul or experts in all those technologies. We're just trying to design it in a way that we know how to control them and we know how to react. I've been, for the Grafana setup, I've been following mostly best practices implementation or HA recommendation from Grafana. For the Prometheus side, it was from the Prometheus side. There's a lot more to say actually on Prometheus because it's a bit challenging to keep the EBS volume or keep the disk. Today, our Prometheus are 1 terabyte, and it's not that much. We can go a lot further, but it's a bit challenging to keep that metrics or those data when you have a container that can be shut down anytime and that should move along. Been following blog posts talking about HA implementation of each piece of those technology and implemented them one by one.
So you did this mostly yourself then, basically?
Yeah, based on what we know and how we know how to manage.
Pretty impressive. And one more question on the console clustering, when you went to that monitoring system to monitor the container images, did you feel you lost any fidelity over what was going on inside those things? Because you said they self-report?
No, to be honest, it's definitely console is really straightforward. You just have something popping up and that announces itself like, hey, I'm this guy, this IP, this port. That's it. It's just a service. It's as simple, definitely. I mean, today we don't use console in a way. I mean, console does dozens of things. We just use the service discovery part of it, like just register yourself into something where we can discover yourself.
But you're confident that something bad isn't going on in those Dockers that it's not aware of?
So, well, we do have monitoring because we do see failures when containers try to register in console and they fail. Console has some health check mechanism that says, oh, that thing keeps like rebooting or coming up with me and I'm not able to perform the health checks. So we have somehow like a way to monitor it. At the end, because we monitor those apps in yellow, blue, green, we know when they are not performing well or when they are not registering properly because we keep track of those things are applications like HTTP application or APIs, and we know directly that there is an issue at the code level. So we are, I would say today, really focused on the application itself, like keep track of the application over whatever CPU is being used on the machine. We do have that information exported by, as you can see here, we have additional daemons running. We have fluentd for logs shipping. We have a C advisor. We have a node exporter that gives us a lot of information about the EC2 host. But also C advisors gives us information about each container and traffic itself gives us how many requests are being sent to those containers. So we do have a lot of levels of analysis to find out if one of those.
You have just as much confidence as when you were running pure EC2.
Yeah,
Okay.
definitely. Yes.
Just really quick, you said you're running Prometheus as a container, correct?
Yes.
What kind of resources have you allocated to a single instance of the container? Like CPU, memory, so forth, that's handling a terabyte of your time series metrics?
Yeah, so so today, actually what we do is that whole ECS, it might not be clear, I keep adding logos and things to that diagram, it's too much. We don't pay for CloudCraft, so we have like this tiny grid, so I can fit everyone in there. By the way, that's an amazing tool. I love it. So we, on that ECS cluster, we basically run C5, 8 pixel or something. Prometheus, to be honest, so far, we haven't had any CPU memory issue. We have about 1,000 hosts registered in Prometheus. But we're not at such a scale where I think we're like facing issues yet. To be honest, like we haven't put like so much thoughts into CPU memory. I think it's just like roughly basic. It's just a disk that has been causing issues in the past because when we add some systems, we don't really have issues. So, oh, is that guy just gonna handle it? Yeah, it's like right at some point. So I couldn't tell you exactly. To be honest, for now, it's doing okay. It's like running on pretty big boxes, but no crazy setups or no crazy tuning.
What about for like provisioned IOPS on the volume?
Provision IOPS. So we have a we have a terabyte. I think right now we use SSDs on AWS. It's 1 terabyte. So we get like IOPS. We don't use like provision IOPS, and that works pretty well. Yeah. We have a scribing tool which is 30 seconds, and it's been working well so far. So I think we'll just that was like a beast for us that one month. Like we did all of it at once, like service discovery, Prometheus profile, management push gateway. There was like a lot of elements to put together. I think we'll just learn from future outages and adjust like what's needed. I have a question.
So you said you have 1,000 nodes in your console cluster.
Yes.
And maybe it crosses multiple regions. Sorry. Do you have to segment by like in your console cluster by data center, or do you have just one flat console cluster? And
That's a good question.
Any
So
latency?
actually, for now, we have four accounts. We do run one Prometheus cluster per account and per region. So that's how we don't make console cross region or cross, like every region is isolated for now because we haven't had the chance to actually or have the need to cross the data across like different regions. And usually people just focus on, oh, this is a problem going on in one region and we need to have insights about this region. So for now, it's just like a simple, I would say, standalone console cluster per account per region, which works pretty well. I think in the future, what might be doable, and that's a pattern that I've seen about like federation, having like a Prometheus of Prometheus. So you have another, it's a lot of inception in that word. You have a Prometheus cluster that is actually over here, taking all the metrics from all your servers, but you can have another Prometheus on top of it that checks the other Prometheus instance with a smaller granularity or like higher granularity. So to be clear, you may want to have a Prometheus server where you have like a year of retention period of data, but that Prometheus instance might have like an hour, like it scrape data every hour and collect data every hour. So you definitely don't have like a small granularity, but you can see what's going on over a year. So that's also a pattern to aggregate data across maybe different data sources where you don't need like near real time. So that's something that we're potentially evaluating if we need to have like maybe more global Prometheus or more global like data analysis across different accounts. Cool. Thank you. You guys have any final word?
Yeah. So thank you guys so much for attending. I just want to let you know that we do have the next meetup scheduled. So just a reminder, every 2 months we like to meet. So we'll be meeting next time around mid-August. And a preview of that, we'll be talking about continuously living Terraform, maybe using some tools that were mentioned today, like Atlantis. We're also looking for a second speaker. So if anyone's interested, if you want to maybe talk, we're looking for talks in between 15 minutes and half an hour, ideally. We'd love to have you check that out. So if you're interested, let me know. We'd love to get you involved. So yeah, if you have a tip, want to speak, talk to us or email us, or yeah, right now we're the best. So thanks so much, and yeah, have a safe ride home. You guys are great.
Novocaine, I keep it coming, so I feel no pain.